So this is the Operations Roundtable. We did a presentation yesterday. CCP RAM and myself, CCP DeNormalized. Maybe the other guys can just introduce themselves, and if you guys have questions or something like that, just please ask.
All right, so I'm CCP Luca. I'm the network admin. I keep live online.
I'm CCP Hidden. I'm infrastructure sysadmin.
Well, you,
I had a presentation yesterday, but I'm CCP Ramp, senior sysadmin. Been at CCP for 14 years almost.
Peroxide, I'm technical director at Shared Services, which includes a lot of this stuff that we're going to be talking about.
I'm CCP Marshall. I'm not ops. I'm just here for fun.
Wanna be ops, by the way.
Honorary ops.
It's more like a dev ops.
Yeah, we said in our presentation, or CCP RAM did, how we were the envy sometimes of other departments. So we get
You want to be in our offsites. Epic.
I'm CCP Jimmy Chung. I'm here for moral support.
Thank you.
So yeah, open questions. Whatever.
Do you prefer to measure success in the fact that nobody is complaining and or reporting issues within the environment?
So player experience is our primary thing.
Okay.
So if you enjoy the game, that's success. And a lot of the stuff we do obviously affects how you enjoy the game, as in connectivity, latency, connectivity, and performance, backend performance, client performance. But we don't do client stuff much. There's some stuff in there maybe that we receive from the client, but success is basically, can you play the game? Do you find it fun? That's success. There are other things like quality assurance and stuff like that comes, but that's all of those pillars are supports for your enjoyment of the game, essentially.
Which I enjoyed the game. I'm not a big complainer, but that's why I asked the question, because no matter how hard you can do it, I know this group of people I play with, we always complain. We'll find something wrong with a perfect product.
Yeah, well, if you didn't complain about things that were wrong, we wouldn't know.
Right.
So we actually do value feedback. Sometimes we get a little, those swear words are a bit heavy, but but aside from that, all feedback.
But of course, it's also often the case that we hear about some issue internally, and we always ask, are players complaining about this? There's a player, affecting thing, and then of course it becomes a lot more of a priority if it is.
Yeah. There's also one thing, we try to know about things before you know about it.
Right.
But obviously there are limits. It's a very complex system, and there's a lot of interactivity in there that's difficult to monitor effectively, but we try our best to do that. So that, often when things come in like, latency in this region or something like that, the network department will already know about it, but still, sometimes we won't, and we won't until you actually tell us about it. Most of CCP has a large majority of CCP actually do play the game, but we're maybe a little bit on the edges, on purpose. It's your game, not our game. It won't, you know what I mean?
Yes.
That some of the complex interactions might not come up in our playtime. So all feedback welcome, and success is measured by enjoyment, really. I think that goes across the company, not just us.
So what kind of monitoring do you have on the state of the infrastructure? So let's say there's a big fleet battle. What do you have, key metrics in place for detecting those events and then the kind of the fallout of those kind of battles?
So generally we'll know. You're pretty good about telling us, hey, we're going to have a huge fight here, or we can kind of see what it is. Sometimes we don't.
Fight notifications. So
there's a tool.
So there are tools to do that, but obviously it's an emergent game, so we have to react to things as they emerge. The ways to do that, there are several ways to do that, but yes, we use a lot of monitoring tools. I think a lot of our jobs are basically about the monitoring, setting up the tools, keeping them working, actually getting the metrics we need to be able to measure the things we need.
And how much of that is gameplay related versus infrastructure? So like, is it kind of like you've got servers that are running hot and we need to like work out what's going on now, or is it kind of in-game information that's you're sort of monitoring the state of like how many ships are in system and then you kind of infer how much infrastructure you need?
So we have both.
You're asking all the questions.
Yes. I've been a DevOps for 5 years, so I've kind of running science.
Yeah, we measure both. So we measure the infrastructure and in-game activity. So we have a system that tells us as soon as a player the player count spikes in the system, it will start alerting us on it. And usually in cases if there is, for example, a fleet fight going on in a system that's not been pre-mapped in our system, the rule of thumb is that we disconnect everything else from that node, pretty much. So if there's like 50 other solar systems, we literally kill that and move it elsewhere, just so that fleet fight can continue to happen. Because I mean, if you have a situation where someone like within a Titan accidentally jumps somewhere, which it has happened, and a fight starts, and if you actually move that fight out, you have to disconnect everyone, and the fight never happens. So we have tools to measure all the in-game activity, the players spiking in the systems and stuff like that, and on the servers themselves, like CPU increasing, memory and stuff like that.
So I can speak a little bit to the gameplay side of things. We are experimenting with exactly that. Oops, the Titan just jumped somewhere. That's probably an indicator that something's going to happen. There's also stuff like with the keynote, the release of the prototype kill mail information. We're also using that kind of information to predict staging systems and understanding where people will be moving massive fleets. We're still toying with these ideas, but it's getting pretty accurate that we can predict, even without a fleet notification system, what's about to go down. And that's a combination of us working with ops for supporting services for that. And then we're still figuring out how we're going to roll that information back in to actually act on it.
How disruptive is that when you've got to react to a situation where you realize resources need to be thrown at an in-game situation, so clearing a node so that, you've got day jobs, right, you're doing your normal stuff, and then all of a sudden the red alert goes off, hey, we got to react to this, there's things going down the system.
So it used to be that the customer support department called ops when this happened, and we did the work, but we actually gave them the power, so they were 24/7. So they're always
we just don't do it anymore.
So we don't have to
just pass it to them, and they're in a better position to make those calls anyway. We're not really aware of who these people that are fighting are, or which who should be disconnected. We don't want or.
And we woke up at 3 a.m. in the morning. It's just like we're not like.
So who do you hand it off to again?
The customer support. The GMs.
Gotcha. Oh, cool.
So they have some power.
Last year we were talking something about secret architecture behind on this roundtable. Behind even you were telling us that you were looking into always on clusters. Have you proceeded with this, or was it just scratched off the map? I think it was about performance, but from your side you wanted to aim at a performance game, but you also had some kind of budget difficulties to go down that way. I think you told us last year.
So we have been using Always On for a number of years now, not on the TQDB itself, but we use it to kind of as a slight replication hack. So some of our content databases, we have Always On replication happening between both here in Iceland and then our Shanghai office and in London as well. So, but again, that's not really like the production game database. We are really, really close with it, and probably within 6 months it'll be operating like that. This read secondary will be here in Iceland, and we will use it for disaster recovery, but also to do some possibly routing of ESI calls, just to relieve the primary database of some of this. The third-party API stuff probably accounts for 40% of all read activity on the game DB. Wow. So like it's huge. Of the maybe 6,000 to 10,000 calls a second, like it's probably accounting for 2,000, 3,000 of those.
probably 2/3 of the traffic overall as well.
You know, if you reroute, you can save actual load on the main database for the game.
Yeah, Eve doesn't cache very well is the problem. You guys move around a lot.
Yeah, we can too. I'm sorry.
So you cannot jump the gate. It's still in the cache.
Oh, I wish we could do that. That would be the best, but also be the worst.
So on that note, how are you actually doing the primary databases, I guess, real-time replication for failover? Are you just using regular SQL replica?
No, it's just a shared SAN. So we just have two physical nodes, and it's just shared disk storage.
Just a standard failover configuration?
Yeah. Of course, the SAN is replicated as well internally for redundancy there. But otherwise, yeah, it's just two physical. It's actually 4 physical servers. The two. If some of you guys were in our presentation yesterday, you've seen the process of joining these 2 machines together.
Yeah.
You may not wanted to see that, and so I apologize. But so yeah, it's kind of 4 like that.
Have you done any measurements of the performance difference between just having that shared node storage versus doing an always-on synchronous replica?
Yes. Both next to each other and then also between data centers. And there's definitely latency that gets introduced there, not just on the secondary because it starts to fall behind due to bandwidth limitations, but depending on the replication type that you're using, async or sync, the primary can really get affected. And they're really kind of scary design decisions you have to make because even if it's an async replication to the secondary, that can still impact the primary. We have to be very careful that once we start to open up the secondary to API calls and maybe internal reporting tools and things like that, that can still, in some cases, block the primary. You just have to be really, really careful.
Yeah, I've had some recent fun with that.
Cool.
So just to a question from an impact on the ops from a gameplay point of view. With the Ultra Gladian thing coming out and yesterday at the Roundtable, they mentioned that when you go into in one of the pockets of the abyssal pockets, you actually are moved out of this node of the system you are in. So I was wondering how would that work? Do you create a node for every player and run it on the servers? How many are you expecting to be created? Is that a problem of concern?
I guess it would be handled maybe like the tails and the incursion systems.
Yeah.
So the way that all of the services get laid out on we have 240 nodes that we allocate different services to, and so this cluster mapping works in such a way that we just give it a particular cluster mapping, and then this node will only accept services that have an equivalent cluster group. Say they join that way, and so we can just dedicate some nodes to this abyssal space things, and then whenever that session change happens, I guess what it would be is they would just switch nodes then.
Yeah, it would be a different connection. So what Jeff said is that ultimately we have roles that each of the nodes play, and then you can map those out. And so when they're saying that they're remapping or dedicating a node, it basically means that node only has one job now. Most of our nodes have many jobs.
Okay.
And so that might be a lot of null sec systems that are low traffic. One node might be handling all of them, as opposed to, if you're having abyssal locations, it'll be roughly the same idea, where abyssal is interesting because it also introduces the idea of they don't exist all the time.
Yeah.
So that's going to be actually a welcome concept within cluster mapping. You don't have to have them all the time, so that gives us a different paradigm to work with.
It's going to be kind of like we're going to have a slew of extra hardware for day one, and eventually you can shrink it back down.
Yeah. The initial for that's going to be interesting. Yes.
How does abyssal space differ from traditional machine running when you walk to a location and go through a jump gate? Is that handled differently than abyssal space?
I don't know the details on that right now. It will be a different system location, which means it won't just be an acceleration game. So you won't be within that same solar system anymore.
For us in operations, it means nothing, right? We have no real visibility into that level at all.
So you just provide a series of nodes, and then the client developers decide, okay, we're going to stick
absolutely
connecting to some other partner.
Yeah, and depending on how that develops, it might be on the same node as that solar system, just for sanity purposes, to like keep the load predictable, as opposed to making their own nodes and then all mining abyssal stuff when everybody jumps at the same time. Who knows, right? So whether or not it's an acceleration gate type concept or a jump gate type concept, I think they're still toying with that idea.
I was in the game events, the team there yesterday, and they talked a little bit about some of the game design and programming and things like that. But what they brought up, one thing was there have been regular, and maybe y'all brought it up too, but there were regular requests for database copies. Now, are you staging to say like test servers or test environments, or are you cloning or spawning or spinning up new VMs for them every time? Are you actually doing a straight database copy at that time, or do you have some sort of a repository where somebody asks for it, you just spin it up for them and it's ready for them in a couple minutes?
It's 4 terabytes. It's not easy to do.
Fair. God, I wish it was ready in a couple minutes. That'd be great.
So the TQ is in London, and all of our test servers and stuff are back here in Iceland.
Gotcha.
So then there's also that separation. With Always On, and once we get this real-time replication happening in between, we will certainly be able to offer that. We have a new SAN in our data center here now, which has got all kinds of fancy features to be doing snapshots and things like that. Our existing SAN does as well. So what happens there is every single night we transfer a full copy of the database back here anyway, so that research and statistics department, the data platform team, can do. They have processing that runs for hours and hours overnight to spin up cubes and all sorts of things. So we typically just steal a copy of that. We've already, we're copying it every single night anyway. We restore like a master copy on just the volume on the SAN, and then we just spin off snapshots of that and provide those to the 15 or so test servers. So any of those, the dev teams, and their QA people will just say, okay, we need a copy. So we have a list of test servers, like 15 of them or however many it is, and we would just have this point in time in TQ, and we just spin off snapshots, provide those to them. We have multiple of these masters. Of course, data gets stale, and teams need to just a refresh of the data, of course, to be able to test things. So we have multiple of those, and we just kind of cycle through them, delete them when they're old, and restore. But with Always On, hopefully, then we can start to provide like real point in time, just instant copies for people.
So on that note, then, how are you doing backups for the SQL database? Integrated SQL backup and SAN snapshots, or?
No SAN snapshots, just native backup. So to disk, and then I think it's still TSM.
No,
that's pulling it.
No, Veeam is.
It is Veeam now. Okay,
yeah, Veeam now.
We have switched over, but yeah. So at least for TQ, we looked into like Veeam can just take the backups itself, but a lot of these products use VSS, and that takes a snapshot and QS's the disk and pauses all I/O. And even though that may be like super fast, and it's not, it's still in the seconds of time that it takes to do that. 10-15,000 transactions a second, something's got to kind of pause and wait, and we don't necessarily know the impact that that's going to cause on you guys. So for now, yeah, we do it this way. It's easy and it works.
I mean, I've seen with VSS-based backups using Microsoft DPM product.
Yeah.
I've had noticeable pauses with SharePoint, so I was getting my backups overnight.
Did you have a question in the back?
Is your current limitation technology-wise, or is it just money? If you said if you extra million overrides, we will be a lot better. Or if you just say
time and budget too.
I mean, it's both, right? Definitely. We can continue to throw money and make fleet fights. I assume like that's kind of the only real limitation.
I mean, in general, we always had defenses, how whatever.
Yeah, for sure.
Wanted to have.
There's not really a whole lot that we could go higher in hardware. I think from operations, because we're not programming, we can throw them under the bus here. It's more that. He's here for moral support, though. You're on our team now.
I mean, there is a theoretical limit for how much state replication we can do over networking, which requires CPU power. And while we're running on cores, on physical cores there, we're not distributing, because we can't really, this is a real-time simulation, then there is just an upper limit what we can do. And the programming that's going on is a lot about making more space in that core where we can actually have more in there. I'm not gonna take this.
I mean, it's there's two problems that we have. One of them is we're running on one core, so that becomes a scheduling nightmare for anything that we do. The easy wins that we're looking at right now is just getting data off the node, because that's ultimately our problem. Like in fleet fights right now, the biggest, the easiest win that we get with fleet fights right now has to do with the transmission of the data. Because right now, when you have 6,000 people in the system and one of them goes bang, we have to schedule bang, bang, bang 6,000 times. And that packet is sequential on every single client. And that takes up a ton of time, as opposed to send out a bulk message and then spread that across and then dump it into another programming language that knows what parallelism is, that's not Python. And then send it everywhere. And then, that's one of the easy ways that we can do, and that's something that we're looking at. But then ultimately, it does come back to the simulation pieces of it, where we don't have a distributed simulation mechanism right now. And there's been a lot of talks on, if you guys know the Brain in the Box project from a few years back, that's also been, we've been theory crafting around the concept of ship in a bottle, which is this crazy idea of we give each ship an instance on Amazon. I mean, it's not, that's throwing money at the problem. But we have to parallelize this somehow and deal with those two things. But that's the two main things right now, is ultimately, we're hitting the upper limit of not only the processing power that we have, but simply the logistical concepts around distributing the information. We can't get the information out fast enough with the tech stack that we have right now.
Are you looking at new technologies and processors, like what is going to be the new release of a processor by Intel in the next 6 months or something like that?
I was going to bring that up.
Something that you actively look at?
Maybe a little, not active. We're not absolutely waiting for the next CPU to be able to go and buy it right now. I don't think so anyway. We're tech nerds, right? We always love looking at these things, and so we are definitely aware of what's happening.
The clock speed improvements haven't been that.
I also want to say that just right quick. When you're doing sequential scheduling, like we're doing, clock speed is king. And clock speed has not been increasing. I mean, we've been kind of taking around on the enterprise space 3 to 3.4 gigahertz, and it's not really going higher. It's going, what is driving this forward is multiprocessing, thermal load control, that kind of stuff. And while the processing speeds are in the same place, and we're not multi-core, there's not much we can get. We could buy CPUs for 10K or something like that, but it wouldn't give us much. It wouldn't give you much.
I mean, if Google gave us their D-Wave for a while, that'd be nice.
Yeah.
You can always move to a IBM Z series with 5 GHz CPUs.
Yeah, we had to recompile the whole thing, so. Sorry, you were.
You guys, in the last dev blog that I saw, you guys are running off of E7-8893 V3s, when currently the V4 series came out, which have more cores and slightly lesser clock speed. Are you guys on an upgrade cycle to upgrade to something higher than 4 cores or something like that?
We don't need it at the database level. So those are database CPUs. Our always-on node though does have that new chip, just because we got it, after that. So it's just a single box that's here nice, and but it is running that V4 chip.
And also, just to on the simulation side, until we're multi-threaded there, clock speeds are basically, they're static, and core, we can always add cores. And we have actually quite a lot of cores that we could spread things over, especially if we have, say you have 5,000 people fleet fight. If we could spread that out over 4 or 5 cores, or hell, say 100 cores, we have a significant percentile of active players are in that fleet fight. So we kind of disconnect other processes at the time, or move them and share cores between those, and move everybody, that whole fleet fight over multiple cores. That would alleviate that problem immediately. So that would be that's a greater gain than just going for more CPUs or better CPUs or more cores.
Yeah. No question talking about better CPUs, and what I've noticed in all these years, using mainstream server CPUs, and then they introduce special CPUs with actually 4 to 5 gigahertz clock rate even actually right now, which are usually sold to Stockholm computing companies and so on, but they are reachable for everybody who throws the money at them. If you look at those CPUs, because, well, they would be ideal if you run them single thread.
Yeah, but again, a bigger gain is going multi-core than trying to reach for those cores. And we are also limited by what we can put in our centers. And we have some, you might be able to describe the Everest nodes that basically are slightly higher ones that we're trying to move the fleet fights over onto when they're happening. But there's percentile gains there. And considering that we're already tight-eyeing, that it's not, the gain isn't going to be enough really to justify changing architectures, recompiling for those, or re-optimizing for those processor architectures.
No, I mean, they are 68, they're just...
Yeah, I know, but we're doing, for CPU optimizations as well, just to gain those few percentages, so...
It's also about like the update cycle as well. So you buy hardware that's like supposed to last for 5 years, right?
Mm-hmm. Yeah.
And so the kind of the mentality right now is like, okay, we've updated TQ recently to the Tech 3 is what you guys call it.
Yeah.
And then it's kind of been a decision. Okay, the clock's ticking. 5 years to get off of a single core.
We have 2 years left, I believe, on this hardware cycle right now. Late 2015 is when we moved into the new data center and we bought all brand new hardware for that. And so I think we're like 2 years left. And then
we will look into new hardware next year. But we don't know. The problem is always going to be that the higher CPU we get, I mean, just more players are going to be on there. And
it doesn't matter what we buy, you guys
which is great. But the real goal is to support these huge battles, with at least minimal tie-dye, right? So multi-core is still the key to that. Yeah. And if we go multi-core, we also gain like the ability to be able to do hybrid systems where we can there's a huge fleet fight. Instead of moving stuff around on the on-premise cores, we could technically spin up some instances in the cloud and run it on there, the huge fleet fight, which would give us a lot of additional benefits. Just not just having more instances just for that period of time. We could spin up like the C5 instances, or large C5 instances in AWS or the equivalents in the other cloud providers. But until we get multi-core, we don't gain anything by that. We might as well just run on those cores until we get that. And there are, and other efforts that are kind of offloading other things apart from the simulation off the cores. That work is underway, and it's been, a lot of the stuff is already done, but the gains are so small. Really nice. So,
I have a question. Maybe.
Run.
We should actually be able to run like hybrid now, shouldn't we? Like we were talking earlier about having this abyssal space or anything with these cluster mappings, right? These dedicated nodes. We should easily be able to do that right now.
So we talked a lot about that as well, because this comes back into. I'm not sure we talked about that part, but it comes back into the idea, like we were talking about earlier, is the fact that the abyssal will be on demand, and we haven't really had anything on demand before. Like wormholes were always dedicated.
Because cloud is perfect for that.
There was always static ins and outs and that kind of stuff. But if abyssal goes to a system instead of a dead space pocket, that might depends on how they deal with that, right? There are other decisions that need to be made about whether or not you move it off of a location node in that situation or not. So I don't know how that's going to work out, because there's a difference between. Oh, you guys remember when we had session timers? Yeah. So I mean, they're still there, just less of a pain in the ass. That would be a subtle difference, right? If you were on an acceleration gate, you wouldn't get a timer, but if you went to a different system, you would get a timer. And so that might change some of the dynamics of like crime watch and various other things. So I don't know where that's going to land yet.
Yeah, there's also things like database latency for on-prem into the cloud. We have to test. I mean, we have run Eve in the clouds already, so we know it works. Just there are architectural considerations going there.
Yeah, there's been some experiments that we've been doing for the API. Like we would love to offload fitting simulation. Like you know how you guys have ghost fitting now, right? We want to park that on a node and then not connect it to anything, and then just put it on an instance in AWS somewhere, and then hook up the API to that. That way you can send fittings and get proper feedback from it. Like that will actually work with that set of data instead of using the wonderfully reverse engineered like Python and all that good stuff.
Yeah.
But that's another part of the hybrid piece that we've been experimenting with as well.
So when it comes to testing on the cloud, have you tried developing for something else than just like spinning up instances like container runtime or let's say lambdas and...
Yeah. So all other games except for Eve are running on various architectures in AWS. So Spark, Valkyrie, all our new projects is all cloud-based. And we're using Kubernetes extensively in AWS and in Google at the moment. And we're doing Lambda development as well. So new projects are generally, when they ask me what should we do, it's like containerized and Lambdized.
Ignore Eve.
Yeah, so all our other games are also different from Eve in that they're using Unreal. They're not in the Eve backend. And they're only hooked up to the authentication systems, and in some cases, like Valkyrie is hooked up to the virtual store, and the same thing that the Eve uses. But new systems are generally just they're greenfielded or semi-greenfielded, where we have a smorgasbord of kind of services. Here, you can take this and use this for the new stuff, so we can get things running quicker. And all that stuff is cloud-based. It's all containerized, either containerized or going directly to Lambdas.
So we have put Eve in a container before. And so there's a system called Paparazzi, which is the wonderful thing that takes everybody's picture. The only reason that was able to happen is because we did some voodoo with wine and actually ran it headless inside of the container, which actually outputs the pictures for the characters. And that worked, but it was a house of cards. Like, there were so many things that could go wrong with what we were doing with wine and how the container was set up and the resources that we needed. And we're actually running that in Cube as well. So we've done those kind of experiments, but they've kind of just backed off of it just because of the fragility of the ecosystem there. The other things that we try to do with Eve, like we try to do that with an Eve server as well, but we use OLE DB connections. Which you laugh now, but recently Microsoft undeprecated them. To which we went, I don't know if I'm happy about it.
It was nice to be forced.
Yeah, it was good to have a fire that was like, this is going to be turned off in the next SQL server. We got to do something. And then Microsoft's like, no, we're not doing this. And we're like, good. But we ran into because we're using OLE DB drivers, we couldn't use our wine tricks with those drivers because OpenTDS does not support OLE at all. Like you read
free
up on
TDS,
it, free TDS, that's what it was. And they're just like, no, we're not doing that at all. So maybe that'll come back since Microsoft undeprecated it. That would be interesting. I don't know if we'd still try to do that, but it was a fun experience. So we have toyed with this, but it's untenable at the moment. Yeah. So we have to replace a lot of components.
Right, you just need to port stackless to Linux.
No. I was this close to loading the Go runtime instead of stackless.
Oh hell, I was this close to actually starting it yesterday after pub crawl, but then I decided no.
So basically, me and you should get a bottle of something, and we'll just kind of load up runtime.
Just pull the Eve server code and just go, make. Nope. And start fixing.
So when can we expect a 100% lambdaized Eve? So we just play lambdas online?
Lambdas are his buzzword. He's still trying to convince me of them, but yes.
A large part of the distributed API for Eve might go into lambdas in the end, because once you're containerized, you're running a Linux, going into a lambda after that is trivial. Well, trivial, I say. I don't have to do the work, right? No, but the simulation engine is never going into a Lambda for obvious reasons. This is a real-time application that, when you can't run it, and it contains state, right? Which breaks the Lambda.
Lambda also has state.
Yeah, but it says a 300-second max execution time.
Usually.
Yeah. And Lambdas are great, but for real-time worker applications, they don't work that well because they're designed for stateless request response or short-term jobs. And for that, they're fantastic.
And without going into things that we cannot talk about at the moment, there's also the consideration about the AWS infrastructure in China.
Yeah.
What's supported there.
Yeah.
So, yeah.
But yeah, Lambdas are fine. We're using them, but they're not going to be much into Eve for a while, except for extreme use architecture, the supporting services.
So I don't know how much you know about this specific question, but so when a fleet battle is happening on one of these nodes, what are the record points? What are the actual writes that you get out of that? Because obviously there's a real-time distribution of position and stuff. But then I guess like the destruction of ships and fight using of ammo and stuff, that would cause a write. So what do you actually record as a result of the fleet battle? Is there like a long-term snapshot of the actual?
No, that's all real time being dumped in the DB. The persistence is almost instantaneous whenever we do anything in Eve, and that's kind of how the system is set up. Like the only time that we start doing transactional concepts is when we tear the cluster down, and then it's just like, oh shit, I better write all this down, and then like all the nodes just start dumping into the DB. But usually while the game is running and doing the simulation, like as soon as you use ammo, like that's another thing about fleet fights and how they work is that a lot of that is DB time coming back, where it's like, bang, okay, let me write that down, and then that comes back from the DB, and then that actually happens. So the DB is the authority on what can and cannot happen. I mean, it's a kind of a running joke internally, but Eve is just an SQL service.
So is there something conceptual in that in terms of like that's the way you intend it to be, or because I can imagine you building this so a fleet battle happens on a node, and until that fight's finished or someone leaves the node and kind of flies off, you could have an opportunity there to isolate that entirely from the main DB and only record the result after it. So you can like shard that part of the database and say, right, you do that database and ignore that from the rest of the world until you've finished, or until it's kind of comes back down to manageable levels, and then the main DB.
So Eve is one huge ACID transaction, and there's no eventual consistency really.
No.
Correct me if I'm wrong, there's no base anywhere. One of the multi-core things is basically we're going to have to have eventual consistency, because as soon as you go beyond a second, you're in base. You're no longer in ACID land. And once when you have frames that need to go every 16 to 30 milliseconds, you can't distribute that properly without having base transactions. And then you have to introduce things like optimistic results, local results. Kind of part of all these progressive applications that basically go like, hey, I do this, I expect this to happen, I do things, but this might take a couple of seconds to go through the system. But at the moment, we're just, hey, an ACID transaction, like a paddle, does everything immediately, and it doesn't respond until it comes back from the database.
But that's global across every single system, so there's two fights going on to entirely parts of the universe.
Yes.
So they've got to come back to the same data.
What you're getting at is like, we should treat it like a first-person shooter, and you have a fight, and then record the results.
The database is not a limitation that's except getting the data on and off his nodes. So even if it was abstracted or isolated, he would still have to do that, and there's just really no gain there. The database typically just running, we idle at like 20% CPU, basically, like it doesn't get hit that hard. So unless he can keep it on that node and keep it there and not have to do that.
The RGB is a beast, and Eve just does really dumb things with it. So that's not really the problem. A perfect example of that is like if we have a hiccup on a network, like basically across the cluster, Eve just goes, oh, my DB build went missing, I'll reconnect all the time, again and again and again and again. And then the DB goes, I don't have any sockets left, fuck off. Yeah. And then D goes down. But back to your point about the disputing the actual data access, this was a big conversation inside of Bringing the Box. Right now, Eve is 100% accurate. When you have 6,000 people primarying one guy, do I really need to go through all of those shots to know that he just died? Like, this is one of those areas where you get into eventual consistency, where it's like, okay, we have aggregators that we're just looking at, nope, he's dead, stop caring. But that's not what he does. Instead, it goes, there were 6,000 shots, guess what? I'm gonna process all of those.
He's dead 50 times.
Just imagine only the first 200 people would be on the kill map. It will be such outcries, so you have to go through.
Yeah, but if 600 people fight him at the same time, like everyone that does overkill usually gets the message, well, the guns try to activate, but unfortunately...
That's why I would love friendly fire to use.
But it also
exploded, lasers on everybody behind him.
Yeah, but basically, for the kill mails, if you're talking about that, the data is eventually, inherently in the name, it is eventually, because it just doesn't matter right that second to everybody else. We're sending 600 shots to 6,000 people, and then, you know, the database is just going on that one, and it's not the database, that's a limitation, like Jeff says. It's not the database, it's basically just the replication, the I/O over network on disk. That's what is the limitation, really, and just cycling through and scheduling all those messages and sending them out to the network. That's the limitation, really.
So that's a limitation. What do you use for networking and technically for SAN? Do you use full-fledged SAN, full-fledged tiered SAN, or do you use normal wired cut network, or you go to InfiniBand, which writes directly into memory, so you don't have the TCP stack in front of you?
Network guy?
Well, I don't know much about the new SAN.
The SAN is a mixture. It's multi-tier SSD, flash, and like SATA disks as well, right? And so just to set it up that way. Fiber channel, it's all fiber channel for SAN.
But network load is not an issue internally or externally. We don't generate that much network load. Everything is 10 gig internally, and we never hit that.
No, I don't mean from the load side, I mean from the latency. I mean, usually you build up 10 gigs in data centers and it's not you're going to use, but you build it up because you want to have better latency. You switch from copper to fiber or whatever.
Yeah, everything is.
So this is basically the CPU doing processing is what is limiting.
So in other words,
it needs to create all the I/O, it needs to open all the file panels, it needs to do all this stuff, and that's what takes time. It's not, it's not, as I said, it's sub-millisecond latency on the database. It's like blade, you know, basically stack, they're next to each other, they're all fiber. That, you know, there's no limitations on that. We never see any blockers there. It's never throttled on that.
The other point is you use normal TCP IP protocol, you don't went to some other stuff which goes directly into memory where you don't have the overhead TCP IP stack anymore.
Something like RDMA.
Yeah.
But even then, we because ultimately, the reason why latency doesn't matter to us is because when we open a socket and put something on the socket, we've already yielded and switched off to do something else. Because there's 6,000 shots that just happened after that we need to tell everybody about. Because by the time we come back to read on that socket what came back, who knows how much time has passed? And it doesn't really matter because there's like shit. And then it finally loops back around and says, okay, cool, you got that, great, I want to go do something else.
Yeah, just from the point of view that TCP IP stack obviously used to communicate a bunch of CPU power. Just from that point of view, I was asking where do you into RDMA?
Well, I mean, again, like even if we adopted a different protocol, it wouldn't matter because of the scheduling and use.
And I'm sure the server hardware has TCP offload anyway.
And again, like that's the other point. Like it is using an implementation of I/O completion ports. So even with that, it doesn't matter because you still have a single core coming back around to all of those requests. So we have to fix that problem first, and then I can make it their problem.
You're here for our moral support. I'm not feeling supported.
I got 2 years left.
Who invited us?
You mentioned before you're slowly stripping things away from the simulation and transitioning over to like a microservice architecture. How's that process going?
Well, we're running into the asset data problem where we have to, you sell something, the other person needs to know about it immediately. It affects the market. Where do we draw the line of here? You need to know. Here, everybody needs to know because it affects the entire market. You sell, however many things of whatever it affects the market. So there are several things like that, and we have there are teams, there are people basically looking at what can we tear out to, because essentially what does Eve need to do? It needs to do state replication and network transmission, and basically the physical simulation. And even the physical simulation can run slower in this thing because it's doing all kinds of things on the client to hide all the physical simulation going on. So we can kind of tear things away. I'm not going to promise much, and Nick, you've got to stop me.
So it's our dream to make everything that's in the neocom accessible 24/7, no downtime. Yeah. Because you don't need space. Like, that's ultimately our goal. Space is where the simulation happens, so if we can make it to where the downtime is just for space, and then you can use the client to use everything in the neocom or in any of the station stuff, that's ultimately what we're going to get to. Because basically, it's like what we've been talking about with the low-level pieces is the big problem that we have, but the other surrounding bit of that is I care about gameplay. Like, I can't rip these things out and then say, oh, now the contracts are available on the API. The market would crash overnight. Like, there's design mechanisms that we have to get out of the way first to make sure the system can handle being on 24/7 and always accessible. Then on top of that, we have to just rip everything out because everything is so tightly coupled with the DB. Everything is like if we start with the primitive of a user, right? Just doing that is a massive amount of work because you might have a station which has a join that eventually hits the user table, and then the question becomes, okay, well, how do I extract a join that goes all the way down to a station level? Like, how am I going to deal with that? And so we're slowly trying to pull all these pieces. These guys have rolled out Chessbin. I mean, that was a huge change, and they have successfully done that. And there's a lot, you know how much that was entangled with all sorts of stuff. And that's another good example of this, where oh yeah, we just want to move the chat system out. Oh wait, that's an Intel tool. Welcome to game design. And you can't just take that technology and pull it out. Like, you have to deal with the repercussions of what's built up on Eve over time. Where, people, like with the first release of it, everybody's like, you can't see anybody local. Like, half of Eve was going, yes! And the other half was going, fuck this, I'm not talking. So it's like we have, even though we want to go through the ultimate goal to be able to pull out everything in the neocom, we can't just go and do that. Like, there are repercussions that are very subtle to how Eve works. We've seen this with the APIs, where when we had Citadels come online, and we had a lot of alliances doing some shady things, where they would just ask solar systems, hey, what Citadels are here? And if you didn't have any access rights, it would return an empty list. But if there was no Citadels, it would return a null. So that became a metal detector for all the alliances going, there's something here that I want. So, there's a lot of little things like that we have to be careful about. It's always funny working with other companies that aren't CCP, and they're like, yeah, we want to build something. And we're like, well, can we just put Chen in here? I'm like, yeah, maybe. They're like, what do you mean? They're like, this is Intel. Like, that is a problem. So, ultimately, yes, we basically want to clean house so that the only thing that's left is the simulation aspect of the game. And then we can concentrate on that when we get into distributed physics simulations and all sorts of other really cool things that we can do there. But there's so much surrounding that it's really hard to focus on that, because we pull that piece out, that trickles into all the other systems. But if we can, ultimately just try to attack this from multiple directions to pull things apart first and establish patterns by which we can do that. These guys have established a precedence on a lot of those types of patterns of what this entails and what we have to deal with. For you guys, I think a bulk of it was ultimately the client side of the UI of a lot of the pieces.
Absolutely.
And they're just making a service, and they're just like, I don't care about the UI.
Yeah, the UI and the Intel was an insane amount of work. I mean, that's time on that, and are still spending time on that. Basically, if it was just a chat client, we would have done months ago on those.
And this is taking off-the-shelf technology, plugging it into Eve, and then basically implementing the entire Eve system on top of that. That's emerged as based on the chat.
Yeah.
But it's running distributed. I mean, it's running completely apart from Eve.
And that becomes another problem. You take the concepts of Eve that are so old and just like it might have been a game designer who designed this, God knows how long ago, and you try to apply it to a newer system, the newer system's just like, why would you do that? That makes no sense. And so you have to either redesign that part of Eve, or punch the new technology in the submission until it does what you want, right? And that's what is the most time-consuming part.
Yeah, being able to stay docked like during downtime and fit out ships and chat with your corp mates or whatever.
That is one of the dreams for us.
Yeah, that's amazing.
But obviously, also that would reduce the number of downtimes we'd have to run.
Yep.
So, obviously the handwave a awesome world would be no downtime distributed simulation at unlimited size battles.
But even that has gameplay implications, right? Like we can't do rolling updates in the universe because you assholes will move with the update line.
Don't call
and take it. But they do. It's amazing watching this stuff. Like people ask, like, why don't you just do rolling updates? Like I can't, because if I change the value of this module and roll through the universe, I guarantee you we will have surfers follow that wave of updates and make money off that as it goes through the system.
I appreciate how you relate to the customer base.
It's not wrong. We have to deal with all the big alliances that won't talk to us about the APIs because we know every time they talk to us, we're like, oh, we have to turn it off. It's a fun game.
So with the chat changes, will local also be available during downtimes then? Asking for a lot from my lines.
No comment.
Generally, we take our lead from the game design department. We don't make these kind of decisions, especially about systems, as you said. I was playing even 2003, then local was already then an Intel tool.
Yeah.
Is somebody coming into 9G in Curse, right? It was like sitting at the gate there, going like, somebody popped up, and going to the gate and killing them. And there was already then like day 2 of the game. So there are lots of these things. And when you take off-the-shelf system, you go like, okay, hey, there's a chat server service. Just, service that we can just plug into the game. It's not a thing to work. Not with Eve, because it's such an old game and has so much behavior built into it. Sorry?
I saw the commit messages.
The commit messages?
Yes, of the new chat server with the code changes. You had it in the Git repo if I was.
Yes. This is right.
Yeah, and I followed the chat notices, the commit messages to follow what has been changed. Like, don't announce to people in wormhole system that someone has left.
Yeah.
But on this end, what about instead non-local chats, like corp chats or I don't know, any special chat you are with your friends or whatever? Is there any idea of implementing it ever? I don't know, like, hey, I can talk with my corp on my phone.
There's a bunch of ideas, but
So going back to containers real quick, have you done any work or looked at the new Server 2016 Docker support and whatnot instead of using nasty wine hacks?
No. We're basically ignoring the fact that Microsoft wants to think they're a Dockerized company. So we're running Linux-only containers at the moment. We're Kubernetes. We use Kubernetes to orchestrate, or we use, we'll probably move into EKS when that becomes generally available everywhere. But basically, we're probably not ever going to use Microsoft containers.
Oh, I was going to say, because you could totally use the nasty wine hack on Server 2019 to run inside a Linux container with Windows.
We discussed it for about 2 hours, yeah. But that was in the infancy of Microsoft containers, Windows containers. But there are far greater gains to be made elsewhere for these kind of things. Since Paparazzi is an on-demand service that is essentially becomes a stateless service because there's only service requests. But we're containerizing Eve simulation. That depends on other things. That's multi-core simulation because containers are designed for stateless services. So yes, you have stateless sets and you have daemon sets in Kubernetes. The concepts are there, but it's not really designed for it. So it's a bit different.
As we were talking earlier about global distributed database in always-on mode, Another question for the network guy. How do you handle this network-wise? Do you go out, you dedicate a fiber line between whatever your data center is and here and the other locations, or you just rent off some random provider, or you just route globally and try to hope some magic that the packets arrive in the right time?
I mean, we have the data center in London and the one here in Iceland, in Keflavik. And we have a connection between them that is through there's one big Icelandic provider that splices that connection through many ISPs. And we have a committed rate to that allows us to do the replication within a few hours. And generally it works pretty well. Of course, the DB is so large that all the things that are replicated, we have to take the scheduling into consideration and not try to do everything at the same time overnight. But
yeah, quit stealing my bandwidth, Jeff.
Yeah, you were talking about Shanghai as well, because it's difficult to get dedicated connection down there. So how would you handle that one?
Well, we do have the same Icelandic company that connects us to London. They subcontract this connection to Shanghai, so we just have a direct circuit there. So internally, everything looks like a routable OSPF redundant network, and we can connect to the Shanghai office and to London and Keflavik without any issues usually. There's of course a lot of latency to Shanghai, just because it is very far away and there's physics limits there. But
stupid light.
Stupid electrons not moving fast enough.
So I heard you talk about Linux and the implementation and that since Apple uses a Unix system, can we have a Mac client?
It's not for us to say.
Not really for us to say.
Fusion and the happy.
Well, there's also a lot of differences with OS X too, because it's using display PostScript instead of X, and all sorts of other different stuff. It's, at least for graphical client work, it's really different.
Yeah. I mean, I have some of the guys sitting near me that have been throwing this around now for years, and it basically always comes down to, oh yeah, it would be very nice to have a proper Mac client, but we'll get to that when we have nothing else to do.
So basically, as long as E runs on Mac in Underwine, there are other things that get profit you better than doing native, basically the client native. And also the client is on DirectX, so we're limited there as well. So Wine we have to have the Wine tricks in between to actually provide the API layer, the translation layer into what is essentially OpenGL on the Mac graphics driver.
Ultimately, it's less of a technical thing.
Yeah.
At this point, that is more of a business decision.
Yeah. Because we have to invest time in it, and again, it's not really on our plate as such.
Yeah. I mean, because the graphics guys have done the work with an abstraction layer, OpenGL. I think people have fiddled with Vulkan at some point in time. So the technical pieces aren't many, but it's ultimately a business decision. You do the math and the time it takes to maintain that on top of another pipeline, and Eve's super old and targeting Windows originally, so it builds up over time. It's maintaining a pipeline that goes to Steam and that goes to our launcher that has an overhead. So adding OS X to that would also just double up both of those pipelines, and yeah, it's ultimately a business decision at this point.
Would that be more of a question for the UI UX roundtable?
No.
I've got a lot of complaints for that one.
All right.
Thanks.
Bye.
Good luck.
Thanks, guys.
Thanks for coming.
Do y'all co-load the data centers, or do you
What's that?
Do you co-locate in the data centers, or do you
Co-locate, yeah.
We're co-located, yeah.
And of course, when we were putting the new servers in for Tech 3 TQ, there was a guy walking on the rack just next to us, and then he took his notebook off his bag, and there was a big Eve sticker in the bag. When I told the guy, this is just the new TQ we're putting up here, and it was just...